Live streaming is on.
Okay, good morning, everyone. What we're going to do today is probability. So all probability is the chance of something happening. So for example, the first thing we're going to talk about, if you flip a coin, we'll pick a quarter. What's the chances that when you flip it, it's going to be heads? So the coin has heads and tails. So what that means is the coin has two sides, and the chance of being heads is going to be 1 out of 2, because it can only be heads or it can only be tails. So you're going to have a 1/2 chance of it being heads. Okay, so another thing that would be, if it asked you what percent that would be, we would convert 1 out of 2 to 50%. So that just means every time you flip a coin, you have a 50% chance to get heads, and you have a 50% chance to get tails. So it'd either be 1 out of 2 or 50%. Okay? Let's do another example. If we do a dice, so the dice would be 1 through 6. Okay, so if you roll a dice, and what's the probability of getting a 3? Okay, so that is going to be 1 out of 6 chance, because when you roll a dice, you're either going to get a 1, 2, 3, 4, a 5, or a 6. So the probability of getting a 3, that's going to happen 1 out of 6 times. Okay, and if I said, what's the percentage? You know, what you're going to do, remember when we're going to divide the 6 into the... So that would be 1, 6, 46. And then if I move this up, we're going to be 36. It's going to be 16.6%. And all that means is 1 out of 6. So 1 out of 6 is the same as 16.6%. So that is the probability of rolling a 3 would be 16.6% or 1 out of 6. Okay. Let's do, let me see here. We'll do another one just so you get an idea. Okay, say in a class, one of ours will say, there are 3 boys and 3 girls. So there's 6 total. What's the probability that a girl is going to ask a question? So there's 3 out of 6. So that is 50%. Because we reduced that, that's 1 out of 2. So it's a 50-50 chance that a boy's going to ask a question or a girl's going to ask a question, just based on the number of people. Okay? We'll do. So if you roll 2 dice, so it's same thing here. So one dice is going to have 1 through 6. The second dice is going to be 1 through 6. So basically, that's going to be 12. And what's the chance that you get a 7? It's going to be 1 out of 12. And then we would do 12 into 100. And that's going to go 8 times. And 12 will go into 43 times. So that's about 8.3% that you're going to roll a 7. Because the first dice obviously could be 1 through 6 in the second. So you'd get like a 3 and a 4 or 6 and a 1. So it's going to be about 8.3%. Okay. I'm going to stop there for today, you guys. But probability, the one thing I want to show you guys is if it's 1 out of 2, we can write that as a fraction or percent. Or if I write that as a decimal, it would be 0.5. So there's 3 different ways a probability question might be asked. Okay. Let me back this up. Okay. So the 1 out of 2, what you would do to get a percent, you would divide the 2 into the 1, and that would go 5 times. So that would be 0.5, and that would just equate to 50%. And what I'll do, you guys, I'll go ahead and post some basic probability so you get some practice at doing this. But this is just probability is all going to be in fractions, decimals, or percent. It's just what probability means. What's the chance of something happening? Okay. One other thing too, I'll just so you guys get an idea. So if you're driving and you come to a traffic light, what are the chances you're going to hit a red light? Well, you have 3 options. You have red, yellow, and I don't have green, but we'll do that. So the chances of getting a red light would be 1 out of 3. Because there's only 3 choices. So 1 out of 3 would be 33% or 0.3. Okay, so you only have 3 options. You can have red light, you can have yellow light, or the bottom one would be green light. So the probability of hitting a red light going through a traffic light is 33%. Okay, or 1 out of 3 times. All right. I will send out the link for science here shortly, and then we're going to do social studies right after that. So everyone, if I don't see you, have a great day. And just remind you, we are possibly starting next week, or probably some in-person tutoring. So if you're interested, please let us know. Okay, have a great day. Bye. Where's my science one?
Oh yes, leave that off there. Who wants this one?
Okay, guys, good morning again. If you're just coming in for science, I'll go ahead and get started. So what we're going to work on today is our solar system. Those about the planets and everything. So I'm just going to go ahead and read this, and then we'll go over some questions. So it says, where are we? This is a question you've probably asked before, but is a question that usually refers to a specific address or location within a city or town. For some people, the question refers to where we are on Earth or even where we are in the universe. Okay. When considering time and size, humans are actually quite insignificant. We've only existed for about 5 million years. In comparison, cockroaches have lived for about 3 million years. In terms of size, think about where you live and work. How far do you travel each day? Now realize the Earth's diameter, the distance from one side to another, is about 7,900 miles, and its circumference, the distance around all the way around the equator, is about 24,900 miles. To us, Earth is extremely large. In fact, we still have not even explored it in its entirety. Nevertheless, even Earth is insignificant when compared to the universe. The universe is so gigantic that size is still unknown. To put things in perspective, here are some examples of what scientists know and suspect about our universe. The Earth belongs to a solar system containing 8 planets, a dwarf planet and the Sun, and the Earth is considered one of the smaller planets in our solar system. Jupiter, for example, is so much larger than Earth that all of their planets could fit inside of Jupiter. Our solar system is located in one of the outer arms called the Orion arm of the Milky Way galaxy. There are approximately 2 billion stars in our galaxy. In the universe, there are thought to be 7 billion galaxies. Why have we not explored the entire universe yet? Well, if you're at travel speed of light, which is about 186 miles per second, it would take you 100,000 years across the Milky Way. Just to get the nearest galaxy would take another 2 million years. So what fills all this space, and how was our small, seemingly irrelevant planet we lived on form? That's what Earth in space is all about. It said Earth's neighborhood in the solar system consists of 8 planets, dwarf planets, several moons, thousands of asteroids, a few comets, and the sun. They all move due to the gravitational pull of heavenly bodies. In other words, anything in our outer space that has weight, and of course a larger body, the stronger of the pull will exert. Thus, moon circles the planets and planets circle the sun. The following are some other objects can be found in space. Comets are small bodies orbiting in the sun in a predictable way, are made of a solid core, dust particles, and frozen gas. They're one of the most spectacular sights you could see, even without the aid of a telescope, because as they draw close to the sun, the dust particles and frozen gas vaporize, forming large trails miles long. The most famous of these comets is Halley's Comet, which last passed Earth in 1986. Alas, we'll not be able to see it again to 2061. Okay, asteroids. Asteroids are very similar to comets, but are mostly made up of large rocks. They are found primarily between Mars and Jupiter in a field called the asteroid belt. They typically will stay in that large belt, but if you've seen any apocalyptic movies, you'll have discovered that some asteroids follow their own circulation around the sun and do occasionally cross paths on planets and moons. Earth, in fact, has been hit numerous times. Luckily, our dense atmosphere causes the break of many of these small asteroids, and it can be seen at night as a bright flame in the sky raining down on Earth. These are called meteors. On rare occasion, large meteors will not burn up entirely, but instead it will crash into Earth. When this occurs, they are called meteorites. It is hypothesized that it was a large meteorite that caused the extinction of our dinosaurs. Without an atmosphere, asteroids have a much greater impact. Looking at the moon, you should be able to see many impact crater asteroids have made. Okay, stars. If you've ever enjoyed a nice sunny day, you would appreciate how incredibly valuable our sun is to us. Of course, the sun does much more than granting us a comfortable living temperature. Its energy also used by all green planets during photosynthesis. The sobering news that our sun is not going to live forever. All stars have a set lifespan and will eventually explode into one of the most fantastic structures you've ever seen, Luckily, stars often live for many billion years, and our sun still has many more left. A star's most useful resource is its energy, yet too much will cause an inhospitable environment. For example, the planet Mercury is only about 30 million miles from the sun and has a high temperature of 472 degrees, hot enough to melt lead. Its orbit so close to the sun only takes 88 days to complete the full cycle. So Mercury's year lasts only about 3 months. Too little of the sun's energy will also create a planet without possibility for life. For instance, all planets from Jupiter are much too frozen. Pluto, usually the farthest dwarf planet from the sun, gets as cold as negative 356 degrees. In truth, scientists believe that besides Earth, only Mars has a chance of having one supported primitive of life, as evidenced by the possibility of frozen water on Mars. Okay. So, the birth of a star. How is a star born? Gases most likely from the deaths of past stars are collected, and they pool into a cloud. Their weight creates gravity, thus pulling in even more gas. As its own gravitational pull grows stronger, the gases contract and dry, and think about what keeps you held down on the ground. It's the Earth's gravity. All the gases pack tighter and tighter. Its temperature begins to rise, finally reaching a few million degrees. Now its extremely high temperature allows a star to act as its own energy source. That's because the heat will transform hydrogen atoms into helium atoms by nuclear reaction. These nuclear reactions, similar to nuclear bombs exploding, produce the energy that we need on Earth. As long as the star still has hydrogen left, it'll keep producing this energy. Okay, and these are type of stars. The yellow dwarf is our sun. The red dwarf, the most common type of star, cooler than the sun. And some stars are older and considered giants or supergiant stars. Red giants, these stars are about 20 times larger than our sun and are red in color. Blue giant are hotter and larger than red giants. And supergiant, the largest of all stars. When this star dies, they form supernovas and leave black holes. Eventually, all stars will die out and form either the following: a white dwarf, which is a small, dense star about the size of Earth but much heavier; a neutron star, a very small star, only about 5 miles across, composed of tightly packed neutrons. A pulsar is a neutron star that is spinning and releasing pulses of light energy. Then you have a black hole, a large area in space that is so dense that its own gravitational pull is so strong, light cannot escape it. It is believed that when giant stars eventually die, they explode or supernova and leave an area called a black hole. Okay, so this is just going to go over the reading, you guys. So it says, how many miles per second is the speed of light? And if you went back to the reading, let me see if I can find it. It would be B. It's 186,000 miles per second. I think that was covered. That was right. Let me see where that one was. Oh, right here in this paragraph right here. Speed of light is 186 miles per second. So the first one is B. Okay, and then it asks 2, what is the largest planet? And that's Jupiter. Okay. And 3, according to the passage, there are approximately how many stars in the Milky Way? And if we go back up here, let me see where it says that. There are approximately 2 billion stars within our galaxy. So 2 billion is what? Would be C. Actually, D, excuse me. D is, that's, okay. Number 4. Actually, there's 2 number 2s. That's why I got confused. I'm sorry. I gave you, oh, excuse me. There's 2 number 3s. Okay, so fill in the blank. Blank are composed of dust and frozen gases. That would be comets. Number 4, burn up before they hit the Earth's surface. Those are asteroids. Most asteroids are found between the 2 planets. That would be Mars and Jupiter. A giant star that suddenly explodes is called a black hole. hold on here. So the answers are down here too. So number 6 actually is a supernova. The stars that are the largest and the hottest are supergiants. And number 8, these are small stars, only about 5 million miles or 5 miles across. And that would be a neutron star. So you guys, all the answers here are just in the reading. So one test taking strategy too that I told you guys, what you might want to do too before you started reading this was you can go down and read the questions first. So I might have gone to the questions. So you read the questions. Then when you're doing the reading, you kind of know what you're looking for, and you can kind of answer them as you come across them. So I went over these, but if you want, all the answers are down here on, I think that's page 9. And then what you're going to do here, this is that Venn diagram that we've talked about, okay? That's when you put some of the characteristics on the left-hand side, the inner planets. The outer planets will go on the right-hand side, and something they have in common is the middle. And you're going to use this diagram right here. So the inner planets, everything, all those characteristics will go on the left. The outer planets will go on the right. And anything these have in common would go right in the middle. So when you're done, see if it gives you, it's going to look something like this. So all the inner planets are on the left, all the outer planets are on the right. And the things they have in common are they're round and they're planets in our solar system. Okay. So that's how you would basically, and this basically shows you all the planets from Mercury up until Neptune. And it basically gives you characteristics on the left-hand side. This is just a chart that describes all the planets. Okay, so, and there's some questions right here that go along with that. So according to the chart, which planet has the largest mass? And you can look up into, so if you look in this chart right here, mass would be right here. It's the third one down. And the one that has the largest mass would be Jupiter. It's 318. Okay, so Jupiter has the largest mass. According to the chart, which planet has the most moons? So you're going to look on the left-hand side. Yeah, let me see where moons is. Number of moons. It would be Jupiter has 63. It has one more than Saturn. So you get onto the all the way down here, number of moons, and look across, you can see that Jupiter is 63, Saturn has 62, Uranus is 27, and Neptune has 13. Okay, and then according to the chart, which planet has a diameter closest to Earth? So we want to look up a diameter. So Earth is 1. So what number is closest to 1? And that would be Venus, which is 0.949. It's almost 1. It's just a little lower than 1. So that would be Venus. And the last one, number 4, you guys, would be, according to the chart, which planet has the longest orbit in Earth years around the sun? So we're going to look up here for orbit, Earth years, and you're going to see it's Uranus, 84 years. Okay, so it takes Uranus 84 years in our years to go around the sun. And you just look at orbital period in Earth years, and you can see Uranus has 84.1. Okay, you guys, I posted a video too, so I will post this lesson. You might want to just take a look at the video as well too. All right, so I'm going to send out the Socialize link, and if you want to join me, we'll start that in about 15 minutes. Okay, have a good day, you guys, if I don't see you.